In this video, we're going to look at a quick way that you can find the vertical asymptotes for cotangent graphs given any cotangent equation. So the key point here is that we are going to apply the horizontal transformations to the asymptotes from the parent graph y equals cotangent x. So if you aren't familiar with what that graph looks like, take a quick look in your graphing calculator or any online graphing tool, and you'll see that the asymptotes happen at 0 plus pi k. So the first one's there on the y-axis at x equals 0, and then another asymptote happens every period, so every pi away. So if you look at this general form of a cotangent equation, the horizontal transformations are going to be the part that are in the parentheses, this bx minus c, or the inputs of the cotangent function. So you only have to take those and set them equal to those parent asymptotes, 0 plus pi k, and then solve for x. You'll have the asymptotes equation and you'll be ready to go. Quick note, k is an integer. If you aren't familiar with this way of representing asymptotes, you simply substitute in different integers for k and you'll get a different asymptote along the graph, depending on what you put in for k. So let's look at an example where we'll actually work through this method. All right, so let's assume we wanted to find the asymptotes of y equals 3 cotangent of 1/2 x minus pi over 2 minus 1. So we know our quick method is to take the inputs of the cotangent function. Those are the horizontal transformations on the graph. So we'll write 1/2 x minus pi over 2. And we're going to set those equal to the parent asymptotes of cotangent, 0 plus pi k. And now all we have to do is solve for x. So first step to isolate, we want to add the constant term to both sides, that pi over 2. So that will go to 0 on the left side. And when we add it to the right side, notice we only have like terms here. The pi k is its own type of term, so it won't get added there. All right, so we're left with 1/2 x on the left side. 0 plus pi over 2, of course, is just pi over 2. And we still have that pi k term. From here, all we need to do now is isolate the x. So divide both sides by 1/2, or an even easier way to think of that is to multiply everything by 2. So on the left side, 2 times 1/2, of course, goes to 1. So we're left with just that x. 2 times pi over 2 is just pi. And 2 times pi k is 2 pi k. So this right here is the equation for all the asymptotes of that graph. So before we finish, let's work a little bit with this to better understand k. Let's say we wanted to find the asymptote where k is equal to 0. All you have to do is substitute in 0 for k. So our asymptotes equation will give us that first asymptote, as I like to call it. So we have x equals pi plus, of course, when we have 2 pi times 0, that term goes to 0. So we know we should have an asymptote at x equals pi. Let's do a couple more. Let's let k equal to 1. Substituting in 1 for k, we have pi plus, of course, 2 pi times 1 is just 2 pi. So we end up with x equals 3 pi. We'll have another asymptote there. Notice that's 2 pi away from the original. And if you calculate the period of cotangent, remember it's just pi divided by b, 1/2 being the b term. Check out some videos. I'll post links in the video description where you go into detail about that and actually graph. But if you do pi divided by 1/2, you have a period of 2 pi, and we know that asymptotes for cotangent should happen every period, once a period. All right, one more let's do when k equals -1. Substituting in, nice and easy, x equals pi plus 2 pi times -1 this time. So that simplifies to pi minus 2 pi, or we find that x equals -pi. That'll be another asymptote for our graph. And notice that's also 2 pi away from the original one when k equals 0. Pi and -pi are 2 pi apart. All right, so to finish up, let's look at an actual sketch of this graph, and I'll make a video later that actually goes through the process of graphing this equation in full. But here is a sketch of this graph. And so you see each of the asymptotes. Sometimes it's just nice to see the actual picture to confirm what we did algebraically you see this original asymptote that we found when k was 0, that's x equals pi. When k equaled 1 at 3 pi, hopefully you can predict when you'd substitute in k is 2, there should be another asymptote at 5 pi if your graph went that far. And you can see the one we found when k equaled -1, make that a little neater, at -pi, extending here, when k is -2, we should get that asymptote at x equals -3 pi. So hopefully this helps you accomplish two things. One, a quick way to find the asymptotes equation for any cotangent equation. And two, helps you better understand that k term in the asymptotes equation. Thanks so much for watching. And be sure to check out those other videos on graphing cotangent graphs.